Okay, there we go. It's recording now. So hello everyone. I'm going to be doing problem number 3, walking home. And excuse me. Problem number 1, USACO 2020, which is do you know your ABCs? So again, just like last time, if you were with us last time, then you would know that I'm gonna read you the problem. Hopefully you did it or you got to take a look at it beforehand, like so you're not walking into this blind. You have a general idea of what's going on. So what I'm going to do is I'm going to explain the problem, do the programming, and basically show you how you get to the conclusion. Because again, it's not useful if I just tell you like, oh, this is the answer. And then copy it down. Like it's important that you know how you get to the answer so that you're able to do it on your own. Because like I'm not going to be here during your actual test narrating everything about your problem. I'm not going to be like, yeah. So I'm not going to be like an invisible voice in your head. So you have to kind of do it. You have to figure out how to do it. So today I hope to help you in that regard. So let's see. So the first problem today will be December bronze walking home. So I'm going to open that up in my browser. So I'm gonna let's first share the browser. There we go. I will open up the link shortly. Copy. Oops. Copy. Oh no, oops, wrong button. Copy. Oh, paste. Okay, so there we go. I'm gonna make the text larger. So it's a Bessie the cow. Oh, and by the way, if you have any questions, just let me know in the chat. I have the chat open. So like if you have any concerns, questions, blah, 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 you can always feel free to ask me at any time. So yeah, feel free to ask me about anything. So we have now Bessie the cow is trying to walk home from her favorite pasture. Okay, I just wanted to double check that it's recording. But anyway, the pasture and the farm are on an N by N grid with her pasture on the top left-hand corner and the barn in the bottom right corner. Bessie wants to go home as soon as possible, so she'll only walk down to the left and to the right. Or sorry, down and to the right. I don't know why I said left to the right. There are hay bales in some locations that Bessie cannot walk through, so she has to walk around them. So Bessie's feeling a little bit tired today, so she wants to change the direction she walks in at most K times. So it'll be K's, she could turn once or she could turn 3 times. I mean, she has to turn at least once or else she's going to walk in a straight line and she's going to basically go nowhere. Now, how many distinct paths can Bessie walk from her favorite pasture to the barn? 2 paths are distinct if Bessie walks in a square in one path but not in the other. So it says the input for each test case contains T sub-test cases. This is like my least favorite arrangement of problems because you could see there's like, they ask you to do a bunch of questions, like multiple test cases in one. So it's, but anyway, each describe a different farm and each of which must be answered correctly to pass the full test case. So the first line contains T. Each of the T sub-test cases follow. So there's 7 test cases here. That's T, and each subcase starts with a line containing N and K. That's N, that's K. The next N lines each contain a string of N characters. Each character is either a period if it's empty or H if it's a hay bale. Why do these boxes come out when I click on the number of letters? Anyway, it is guaranteed that the top left and the bottom right corners of the farm will not contain hay bales. Okay, and that makes sense because if there was a hay bale, then there's no way she would be able to either get out of the barn, like get out onto the field in the first place, or like exit it. So the next N lines can, sorry, I just read that. Output format, you just write T lines, the ith line containing the number of distinct paths that Bessie can take in the ith sub-test case. Does anybody have any questions about this? No? Okay, well, if something does pop up, just let me know in the chat and I will address it as soon as possible. So obviously we have, we have an N by N grid and she could turn at most K times. So she'll only walk down and to the right or to the right. So she's not walking down and right at the same time. So it's not diagonal. It's just either down or to the right. What that means is that basically, that's very interesting if you think about it, because if she's only moving down or to the right, there's no way she can make a loop, right? Because she's moving like a staircase, or she's either moving down or she's either moving to the right. So that's one interesting thing. And so therefore you don't have to use a traditional flood fill algorithm, because in flood fill, remember, in normal flood fill, you have to mark the cells that you've already visited, or else you're just going to visit the same cells over and over and over again, and your program's not really going to do anything. So here, you don't really have to do that, because the problem is designed so that you don't end up in the same location twice, basically. It's like it's designed that way. So if we look at 3, 1, you can see 3 means that it's n by 3 by 3. 1 means that there's only one turn. And a turn just means that you're either moving horizontally and you're moving down, or you're moving horizontally and then you're moving down. Yeah, so just keep that in mind. It may come in useful. And let's see. So if we start in the upper left-hand corner, we have to move down here to the upper left-hand to lower right-hand. We could either go right and then down, or we could go down then right. So I mean, because we can only make one turn, that's why there can only be one kink over here, and that is that kink, or it could be that kink over down here. So it could be down here. It could be either or, so that's why there's only 2 possible paths for her to take. Now let's check down here. We have 3, 2, which is a 3 by 3 grid, and we could have 2 turns on it. Actually, we could have 1 or 2. So remember, we already have this for our 1 turn set. So we have that. So we have one that goes this way. We have one that goes that way. So those are our 1 turns. And those are included in our 2. So 2 includes the 1 turn possibilities. But our 2 turn possibilities include something that goes like this, right? We turn once here, and then we turn once over here. And let me know if something is wrong with if you can't see a drawing or something, because sometimes that happens on my computer. Or it could go like this. You go horizontally and then you go down and then you go to the right. Like that. So I'm going to draw that with those arrows over there. So those are our 2 turn. So that's a 2 turn solution. And you know that because we changed direction twice. Finally, for this one, you could have up to 3 turns. So including this, you can have a staircase like this. You could go down initially and to the right, or you could go across like that. Yeah, so you could see here, the answer to the first test case is just 2, because we only have 2 possible ones. Now we have 2 possible ones with 1 turn and 2 possible ones with just 1 turn. So now we have 4 in total. And here we have, let's see, we have 2 down, 2 more. So we have 6 total, because remember, 3 means that we could have 1, 2, or 3 turns. Let's just keep that in mind. Here, this is a little bit interesting, because you can see the central the central square is marked off with an H. H stands for hay bale, as if you read the problem above. So our problem is that with this, this one becomes obsolete, the one over here and these rows, because they pass straight through the middle, which is not what we want. So we say goodbye to that. You also say goodbye to that because that also passes through the middle. We say goodbye to this one because this also passes through the middle, so goodbye to that. And this one also passes through the middle, so goodbye to that. So you could see here that the only 2 that work either go that way or this way. So those are our 2. Lastly, down here, you could see that the hay bales block off your way. So like there is no possible way that you could connect this period and this period down here using periods, because there are literally no periods in between them. Same thing over here, actually. There are no periods between them, because the H is blocking you from either going to the right or or down. And there's really no way for you to get out of it. So that's why the answers here are 0. Because it is physically impossible for her to go through that route. All right. So again, if you have any questions, just let me know. So obviously the most straightforward way of solving this question would be to use a recursive algorithm, right? Just like a flood fill. Hopefully you've learned about that in class. But in a flood fill, if for those you who may not know or have forgotten, a flood fill is an algorithm where you start on a certain square and then you branch out, right? And then you move here. So you call a function twice in our case, though you call it once for the cell on the right, you call it once for the cell right below it. And in that function call, it calls it again. So you could see we move out in a little network. And you can see that we move out in another network like that. In this case, normally in floodfill, you would mark the cells that you've already visited because you don't want to visit it twice. Visiting cells twice in floodfill is like a recipe for disaster because you like, or it's a recipe for going nowhere because the algorithm never ends. But in this case, we're looking for distinct paths. So at least as long as we're not seeing the same path 2 times, we don't have to mark cells because we are interested in trotting over cells that we have been before, because those are independent paths. Just because we saw it in one hypothetical path doesn't mean that we'll be seeing it again in another path. All right. So that is, yeah, so that's that. So a recursive algorithm would work pretty well. The thing that you would just have, so you would have to just think a little bit, how am I going to arrange this? How is my recursive algorithm going to work? But as long as you think of the idea, at least if you think of a recursive algorithm, you're at least on the right track. So again, if anyone has any questions, just please let me know in the chat or just speak up. You can interrupt me. I don't mind it. All right. So let's see. Okay, so this was a problem I was working on earlier in another class. So I'm just gonna call this walking home. So in public class walk home. I'm gonna change the syntax to Java. Okay, I don't know why that's happening. So walking home. I have to name the file. And again, if I make any syntax errors in here, like if you're following along and then you see like something underlined in red, just let me know so I can fix it. I run the Java compiler manually, so I only see it when I compile it, and I usually only compile it after I finish writing the whole program. So, of course, we have to do our imports, util, and then import java.io. In this case, I'm just going to keep it nice and simple and use scanner because again, the maximum size of the grid is like 50 lines. So at most, you're going to be reading 52 lines. Or like, actually, there's 50 test cases. So at most, you're going to be reading around like 2,500 lines, which is a lot of lines, but it's not an insane amount of lines. Public static void main string args. So I'm just going to be using scanner as equal to scanner system.in. You could also use buffer reader if that's your cup of tea. We will use int t equal s dot next int. And if, of course, if you're following up, please, if you don't know Java, just follow along in Python. At this point, I'm just reading the test files or the test cases. So for int I equals 0, I is less than t, I plus plus. Some of you might like sticking your actual logic code in another function. That's completely fine. Do whatever makes you feel happy. I usually keep everything in a single function just so everything is simpler. It's up to you what you want to do. So just do what you're most comfortable with. So when I'm doing this though, one hint for you is if you like keeping everything in one function like me, you don't want to have this outer for loop contain a variable like I in the you don't want this for loop to contain a variable named I because you're probably going to be using a variable I in a for loop within this. So if you just call it something obscure like you won't ever end up with variable collisions. So just a word of advice. It makes it a little bit easier. It looks a little bit strange, but in the long run, it saves a little bit of time because then you don't have to, because my muscle memory says for me to type in 4 into I equals 0. And then if I can't type that, I have to I have a double take and I have to retype it. So anyway, I will do int n equals s dot next int, and int k equals s dot next int, because there's two numbers after that. And then what I'm going to do is I am going to create an n by n grid. So char, we make a two-dimensional array. And you could technically get away with making a one-dimensional array and having everything, you know, having having a n by n large one-dimensional array, and you just pretend it's a two-dimensional array. But and just for simplicity, I'm going to pursue a two-dimensional array. So we're just setting it up. This makes a two-dimensional array with n sub-arrays in it. We keep this one empty just because we don't want to initialize them. We just want to keep them empty for now. So we do for int I equals 0, I is less than n, I plus plus. There's a couple ways you could do this. One way you could do this is you could read the next line, s dot next, and then you could, for each character in s, you could loop it and make a new char array. But this one is slightly faster. If you need to deconstruct a string into a character array, you would do a of I equals s dot to char array, like that. Either way is fine. You still end up with the same thing. So I can't say one is better than the other. Only thing I will say is that it's a little bit faster. Okay. So in this case, I want an answer variable outside of this method because, again, we're going to have to use a recursive method. And it's better if we we could just pass in parameters everywhere, but that gets really complicated. So if we have a static variable outside of this main method, then it gets a little bit simpler. So I will do static int answer 0. So I will now write the main logic of the main logic here. So we will begin by writing I'll begin by writing a very how do you call it? A very simple answer, and then I'll start adding more stuff to it. The simple answer, you'll be like, wait a second, this doesn't handle a couple things, and then I'll add it, and then you'll kind of see you build on it. Oh, s equals s dot. Oh yeah, that's because sorry, I called this the same. I used the same variable name twice. So I'll just call the string str and str. Thank you for letting me know about that. Yeah, so the reason behind that was because I had a scanner s dot next. I accidentally called the string variable s. Yeah, so unfortunately, so thank you for catching that. So I'm going to now write the solve method. So we will do static void solve. So we'll take two parameters where we want to start. So I int j, and then we'll leave that for now. We'll leave it like that. We'll add more parameters as is needed. So first of all, it looks like our little problem is that we don't know where n is, so we will just take n outside. So we'll just put static in n. We'll put that static into n on the outside, and then we will do that. So because there's already a static field n, so it's okay if you get rid of the n because now it refers to that field. So first, I'm sure this is their favorite part when we solve the question. When the question ends, or when we get the answer, it's when I is equal to, of course, n minus 1, because that's a right-hand corner. Or instead of I, we could say actually x and y. That might be a little bit easier to read. X and y equals n minus 1. That means that it's a possible answer, right? So we make the answers go up by 1, and then we return. There's no reason for it to continue. And also, we would like to start our solve 0, 0. like that. So we would want to call it. Of course, our main problem is that there is no way for us to, yeah, there is no way for us to like move because there's no way for us to move. So we have to add that. One thing that we don't want to do is we don't want to go past the end of the array. Like we don't want to like accidentally turn and leave. So you may have been trained to when you're doing a flood fill to do if x is less than 0, if y is less than 0. But you don't have to do that because we're always increasing n. So increase our if we're always increasing x and y. So there's no reason for us to check that. So we'll only check if it exceeds the size of the grid. Or if y is greater than or equal to n, we'll return. Because like this possible path that we're exploring actually goes off the side, so that's not obviously not valid. We would also like we would also like this. We would also like to be able to see the grid in this method, so I'm going to do that. So I'm going to move this char variable, line number 9. If x is okay, this is line number 9. Do you know what the error says? Because I am not quite sure what the error is. Okay, anyway, just let me know if what the error is on that. You know what? Let me try compiling it. Let's see what happens. Oops. Okay, I do not see a line. Yeah, okay, yeah, it's fine. Yeah, so just make sure you're. Oh, okay. Oh, it was yellows. Yeah, so yellows are warnings in Eclipse. So warnings are never good to have, but if you have them, they're kind of fine. So we have, yeah. So another thing we want to do is we want to have this char array outside because if we have it inside of the main method, we're not able to see it. So what we'll do is we'll just take it out. We'll put static up here and we'll just do that. So we'll take it out. So it's okay if you start writing the program and you're like, wait a second, I have to take this variable outside and I have to put it I have to put it in a field so I can see it from other methods or other functions. That's completely fine. Like don't get wedded to a particular like idea or way of solving the problem. Anyway, we have to now see, is there an H at this location? Because if there is, obviously that's not a possible way for us to go through. So let's just do if A of, remember, variables are always Y and X. Sorry, two-dimensional arrays are always Y and then X. It's a little bit confusing because we have to go down first and identify the correct array, and then we look at the index inside of that array. So like if we have multiple arrays, we would have like 1, 2, 3, 1, 2, 3. So you'd have to go down and identify this third array, then find the element inside of it. That's why it's Y of X is equal to H. Then we return because there's no reason for us to continue. Yeah. So yeah. So we would just do a recursion basically, and we would do solve x comma y. But you're like, wait a second, do we increase x or do we increase y? And that's a little bit of a problem, right? Because you're probably like, like do we do x plus 1 or y plus 1? The answer is we haven't done that yet. So what we need to do first is we need to have a direction variable. So in our direction variable, we'll just say if it's true, we will be moving down. So we have a Boolean D, we'll just put direction. If it's true, we will be moving down. And if it's false, we will be moving right. And it's okay to have a Boolean because there's only two directions we can move. So in this case, we will have to put true and then solve 0, 0, false, like that. So basically, we would like a D, and we would like to explore a turn. So in this case, we could keep going in the same direction. And in this case, we make a turn. But that's a problem. Oh, and then, oh, and we have to, before we get to the problem, if we're going in the same direction, right? If D is true, then we are moving down. So we will increase Y. Otherwise, we're moving to the right. So it's X plus plus. So here we're like, wait, why is this? Why do we say down here, but why are we saying same direction here? It's because we're passing the value of D. Here we don't really care what the value of D is. It's just we're just passing it through. Here we actually do care what the value of D is. Are we moving down or are we moving right? There's no reason why D true has to be down or right has to be false. I mean, you could just switch the two. You could make true right, false down. But in principle, both work. I just chose to do it that way. So our last problem here is that, okay, well, it does everything that we need it to do, but how many times does it turn? Because remember, we were limited by the number of times we were allowed to turn. So what we're going to do is we're going to add a third variable over here. I'll just stick it in between I'll just stick it over here on the left. So we'll put int turn. Well, turns, basically it'll count the number of times we've turned so far. So we will have to call this method down here with zeros. So this is the X. I'll just annotate it for you just in case it's confusing. This is the X parameter. This is the Y parameter. This is a number of turns. Uh, so it's 0 turns so far, so it's 0. So true, we will just want to move down first. And in this one, we move to the right first. Oops, like that. So obviously, if we continue in the same direction, we don't make a turn. So we will just pass in the turns variable as is. However, if we do make a turn, as we could see here, we flip the value of D. So if we were going down, then we go to the right. You do turns plus 1. So the very last thing that we have to do is, what's the purpose of having a turn variable if we're not gonna pay attention to it? So in that case, we do need to take this K out because we can't see what the maximum number of turns is. So we will take the K variable out and we will stick it out here. Like that. I'll show you the whole code so you don't have to, you don't have to worry about, you don't have to ask me to scroll down. You have the big picture. So you will, if turns equals K, then we return, because there's no reason for us to continue going because we've already turned 3 times. We're obviously not there. We're not where we want to be. So we just quit. All right. And I will save this. I'll give you a couple seconds I'll give you a couple minutes to copy it down. After I will make I'll get my sample input and I'll paste it in there. And then I will. Okay, so you could take a look at that. I will compile and make sure everything is okay. Oh, and one last thing, I forgot to mention this. Sorry, I just ran it and I realized, oh, it didn't print anything out. System dot print ln answer. And after you're done printing out the answer, you have to set it back to 0 because we always do answer plus plus, so it's never going to go down. So otherwise, we need to do answer equals 0, like that. Looks like there were a couple glitches in my code, so I'm going to try to work those out real fast. Oh, sorry, we have to wait a second. I am trying to figure out the bug in my code. Hmm. It does not appear to be printing out. Some of them are correct, some of them are not. That's a little bit confusing. Just a second, please. I'm trying to figure it out. Yeah, some of them are printing out correctly and some of them are not. I'm going to try to puzzle this out for a second. Mm. And while I'm doing this, just make sure that you have the code that I have put on the screen. Okay, that's very strange. I'm going to double check this I am going to double check this program. It should work in principle. It is not working in practice. So I feel like it may be an input reading error, but I will double check this in a little bit. So yeah, but in principle, this should work. This is a little bit embarrassing. Let's see. Okay, it looks like a couple cases are not working. Yeah, so maybe I have a feeling. Oops, sorry. Sorry. Its turns is greater than K. I'm sorry. I was looking at the code. I'm like, what is wrong with this? If turns is greater than K, obviously, it will, yeah, it's working a little bit better now. So the problem is sometimes there will be duplicated paths because basically the way this algorithm works, you could prove it. Sorry, the problem again, was right here. It should not be just equals equals. It should be greater than. So if it's like if we do more than 3 turns that we want, if they say three, and then if they say three, and then we have 3 turns, it would have rejected it as an answer. So I'll tell you how I figured that out because could be important. Debugging is important. So basically, one thing that you could do to debug is to figure out patterns in your output that are wrong. So this was the output that I had that was incorrect. It's a little bit hard to see because of the border on my screen, but you could see. Oh yeah, you could see. I will put the code on Discord, by the way, afterwards, so you could all take a look. Yeah, I will put this code on Discord later after the class is over. But here is the code again. But I'll just narrate it while you guys are copying it. Basically, I noticed that first you have to take note of like what cases are working and what cases are not working. Oh, and then I said I duplicated yeah. Sorry, okay, my God, I'm getting a little bit ahead of myself. So basically, this code will go through the same paths 2 times. You could kind of prove that for yourself if you're inclined. So what you have to do is you just have to divide the answer by 2. Pretty simple. Yeah, so fixed, there is a little, I forgot to add that part down there. I was like, why is everything multiplied by 2? And I was like, oh, because it goes down the path 2 times. So yeah, and you need to divide it by 2, and you don't forget to put the turns is greater than K. So the way you debug it is first you have to find patterns in your code. Like, yeah, patterns. So patterns in your output, I meant, not your code, in your output. So I noticed that every single time I had a k=1 solution, it would always print out 0. But everything else would be almost as if they got shifted down by 2. So I was like, what's going on? And I realized, wait a second, so for like k=2, k=3, the answers were, I was printing out non-zero answers, but they were too small. So what I realized is that maybe there's something wrong with k=1 because it's printing out 0. Because the only reason it would print out 0 is if it couldn't make it to the end, which meant that either it wasn't turning or it wasn't recognizing that it hit the end. But then I checked this code, it was like, well, this looks right. So you have to scan each piece of code methodically and say, okay, what does this do? What does that do? And then once I saw this, I was like, if when turns equals k, why would I want turns to not equal k? And you're like, oh wait, I do want turns to be less than or equal to k. So that's why I had to change it. Does anyone need more time? No? Okay. So I will put this on Discord so everybody could take a look at it afterwards. All right. So the next one is a little bit easier. This one was a big recursive one. This one I feel like is a little bit easier. So let me open up that browser again. Let me paste a link in there. Let me close this window. Let me copy the link and then paste it. Okay. Says Farmers John's cows have been holding a daily online gathering on the Moose video meeting. That's I really do like the name. It's a video meeting platform. For fun, they've invented a simple number game to play during the meeting to keep themselves entertained. Elsie has three positive integers, A, B, and C. These three integers are supposed to be secret, so she won't be revealing them to anybody else. So she gives Bessie seven, not necessarily distinct numbers in the range 1 to a billion, claiming that they are A, B, and C. So A plus B, so A, B, C, A plus B, B plus C, C plus A, and A plus B plus C in some order. Given a list of these seven numbers, please help Bessie determine A, B, and C. It can be shown that the answer is unique. So yeah, so yeah. So it says the only line of input contains seven space separated integers. So the output format is, yeah, that is the output format. It's A, B, and C. So okay, so let us think about this for a little bit. Okay. So it says A is less than B, which is less than or equal to C. Okay. And also we have A plus B, B plus C, C plus A, and then A plus B plus C. Obviously, because all three numbers are positive, and because everything is based on addition, A plus B plus C will be our largest. So I think what we have to do first is sort everything. So we have everything from smallest to largest. Because they come in some order, the order that this problem comes in is actually not that important. So we have 2, 2, 4, 7, 9, 9, and then 11. So this is obviously A plus B plus C because this is our largest number. We do know A is less than or equal to B. So let's say if we decide that this is if this is B, A will be within one of these two. We do know that our three added numbers, B plus C and C plus A are gonna be to the left of it. So that means that this is going to either one of these are gonna be B plus C or C plus A. Yeah. Here you could see 2 plus 2 equals 4. So you could probably tell that this is A and this is B. So one thing that you should know is that C can be pretty much anywhere. So let's say A, B, and C is 1, 2, and 4. I assume that they don't really overlap, but they could overlap, I guess. Or 1, 2, yeah, I'll just do 1, 2, and 4 for clarity. So we would have A plus B over here. So we would stick that 3 right in here. So you could see that the first two will always be A or B. And since you know A is less than or equal to B, you know that these first two will always be A and B. So the first one would be A and the second one would be B. So that one is pretty simple. So the real question is, how do we get A, B? How do we get C? Because if we know the first two are going to be A and B, how do we get C? The answer is a little bit, so I guess you could kind of do the math and compare, okay, if A is bigger than B, then it has to be, then, number 6 has to be this one, or number 5 has to be this one. But I would say if you already know A and B, right? We already know that the largest number, A plus B plus C, is going to be the one at the very end. So why doesn't it just make sense if we add A plus B? Since this is A plus B plus C, if we subtract A, and if we subtract the B from it, we would end up with C. So yeah, so that is the idea behind this question. So the real difficulty of this question isn't really us, isn't the program itself, because I feel like that is fairly simple. But the real challenge in here lies in like figuring out how the numbers are going to be oriented, like figuring out where is A plus B plus C going to be. And if you really think about it, if you do enough thinking, you would kind of realize that, oh, it doesn't actually matter where the middle stuff in the middle goes. It only matters the only stuff that matters is the stuff at the end. And luckily for us, the stuff on the ends is the stuff that we figured out first. Because to figure out like what B plus C is, what is C, what is, B plus C, then it gets a little bit harder because you have to like do all sorts of figuring and stuff like that. So this program is hopefully going to be a little bit easier than the other one. So let's return to the text editor. There we go. Oops. I believe that was our previous one. So we will just write, I'll just call this ABCs. So public class ABCs. Public static void main. I'll just use a scanner again after adding my imports. So I will make a new, there's 7 ints that were given, so I'll just make a new int array. Do pay attention to the ranges when you're doing the question. The question says 1 to the 10th to the 9th, which is 1 billion. If you've ever been in one of my classes, I would have tried to hammer it into you that ints can only hold numbers up to around 2 billion. So if you were dealing with numbers that could go like 10 to the 10th, that's when you have to start using long. So yeah, just as a rule of thumb, if your numbers are going to exceed 2 billion, you should be using long, or else the weird things are going to happen with your numbers. Your program isn't going to crash, but it is going to do stuff that you just like, the unexpected stuff. Like your numbers will suddenly turn negative. You don't want that to happen, so just use the right data type. That's why longs exist. A of I equal s dot text in. We will use arrays dot sort on I will save the file. And then so we will just print out our values. So the system.out.println. Remember our very first element, so I'll just make a list, is RA, as we've proven earlier. Number 1 would be B, and the very last one, so number 6, is A plus B plus C. So what we want to print out is we want to print out A of 0, right? Space, A of 1, space, and in parentheses, A of 6, remember, which is A plus B plus C. And we want to take out that A. So minus A of 0 minus A of 1, like that. Does that make sense to everyone? Hopefully it does. So I will, sorry if I will return to it momentarily. There we go. So you could take a look at the code. And it looks like it worked on the first try. So again, this is not a problem though where you need to use for loops. Complicated, like you don't need to write complicated loops, complicated reasoning. You just have to like reason around it. So it's worth spending some time planning things out. Yeah, you should always come into start programming, having some idea about what's going on in your program. Like you shouldn't just walk in and say, you know what, I'll write a bunch of code and it'll all work out at the end. Usually for USACO, you need to plan it out. You need to that you need to put some thought into it. I think is the best way to put it. You just can't sit down and think, you know what, I'm gonna get up. I'm just gonna program it. It always worked out in the past. Like it worked for ACSL. It won't it work for USACO? The answer is likely no. So just yeah, spend some time thinking about it. And then your problems will get slightly better. Or the programs will get slightly simpler. All right. So does anybody have any additional questions about this? No? Okay. So what I will do is this I will give you the answers to these on Discord. So both of these. I'm going to ask that you write the program again. Like there is actually a non-recursive solution to this one, to the walking home problem. So try to try it. You might for an as an exercise, you might want to try implementing it, like the non-recursive version. If you could do the non-recursive version, I think you're going to do very well on the test. For this one, you might want to try doing it an alternate way where you instead of doing A plus B plus C, you try using like A plus B and then B plus C. It'll be a little bit more complicated, but it might be a nice exercise. So you get a little better understanding of it. Because for us, we just saw the first one, second one, last one. Yeah. So yeah, that is that. So I will end the meeting right now, unless any of you have any questions. I will be back tomorrow. I know either you love me or you hate me. I will be back tomorrow talking about, let's see, what's the schedule say? December 2020 bronze 2, December 2020 bronze 3, and that'll be the end of me for the rest of the week. Hopefully, so you guys are obviously going to be very happy that I'm gone. So I have so on Thursday, Solomon teacher is going to pick up where I left off. Yeah, yeah. All right. So good work today. Stick around if I don't have anything else. So have a good night. Stick around if you have any questions, and I'll be happy to answer them. Do you have a question?